This video is about problem solving involving factoring for 8th graders. 8th graders, welcome to your virtual classroom. The following are some simple reminders to make your learning as smooth and easy as possible. Use the module with care. Do not put unnecessary marks on any part of the module. Therefore, you need a separate sheet of paper and a pen in answering the exercises. Don't forget, answer what I know before moving on to the other activities included in this module. What I know is the pretest in each module that checks what you already know about the lesson to take. Read the instructions carefully before doing each task. Observe honesty and integrity in doing the tasks and checking your answers. Finish the task at hand before proceeding to the next, one at a time only. For your convenience, you can pause and replay this video as needed to maximize your learning. Now, let's begin. What you need to know. At the end of this lesson, you are expected to demonstrate understanding of the key concepts of factors of polynomials and solving problems involving factors of polynomials. What's in? Let us recall the terms and the techniques we had in our previous lesson. Factoring is the process of finding the factors of each expression. It is also the reverse of multiplication. What is factor? A factor is an exact divisor of a number. In factoring polynomials, there are patterns that we can follow to make factoring easy and fast. What is a pattern? It constitutes a set of numbers or objects in which all the members are related with each other with a specific rule. Now let us remember these three terms: factoring, factor, and pattern. This time, let us recall the different factoring methods and put these patterns in our hearts and minds to guide us achieve our goal in this video. Here are the different techniques. The greatest common monomial factor, difference of two squares, difference of two cubes, and sum of two cubes, and perfect square trinomial. What is greatest common monomial factor? The greatest common monomial factor is the greatest factor contained in every term of an algebraic expression. For example, 15n cubed plus 12n. The GCMF is, that is right, it is 3. Now factoring out our GCMF from each terms of our polynomial, we have 15n cubed divided by 3n is 5n squared. 12n divided by 3n is 4. Therefore, 15n cubed plus 12n is equal to 3n times the quantity of 5n squared plus 4. What is difference of two squares? the difference of two squares are two terms that are squared and separated by a subtraction sign like this. A squared minus b squared is equal to the quantity of a plus b times the quantity of a minus b. For example, 4a squared minus 16. Extracting the square roots, we have 2a and 4 respectively. And then, following this pattern, follow my mouse. Okay, so we have our square root of the first term, which is 2a here, and then the square root of the last term, which is 4 here. So in this pattern, we have addition and subtraction. So we follow that pattern, addition and subtraction. Therefore, 4a squared minus 16 is equal to the quantity of 2a plus 4 times the quantity of 2a minus 4. Now, what is the difference of two cubes and the sum of two cubes? They are the results of a multiplication like this. We have here a binomial, a minus b. We distribute the terms in our binomial to the terms in our trinomial. A squared plus ab plus b squared is equal to a cubed minus b cubed. In the same manner, we have a plus b. We distribute our terms of the binomial to the terms in our trinomial. A squared minus ab plus b squared is equal to a cubed plus b cubed. For example, a cubed minus 8. Take note that the pattern here is that we get the cube roots of our first and last term, the cube roots. So we extract a and 2 respectively, following the pattern. That will be the cube root of the first term and the cube root of the second term. Now let's work on to our trinomial. Here we square the first term of our binomial. So look at my mouse. A squared is a squared. Then we multiply the first and the second term. That's 2a. And then we square our last term. 2 squared is 4. Now, for the signs, we follow the pattern so, which is same with the given, opposite to the given, and this one here will always be a positive. Therefore, a cubed minus 8 is equal to the quantity of a minus 2 times the quantity of a squared plus 2a plus 4. Lastly, what is a perfect square trinomial? It is the result of squaring a binomial. It has the first and the last terms are perfect squares, and the middle term is twice the product of the square roots of the first and last terms. Let's try one example. Now here, our example is 4a squared minus 16a plus 16. So we are going to follow this pattern because it is a subtraction, and here it is also a subtraction. So therefore, our answer would also be a subtraction. Then we extract the square roots, which are 2a and 4 respectively. And then we multiply. 4 times 2a is 8a. 8a times 2 is 16a. Very good. We have a perfect square trinomial. Now this time, following the pattern, we get our square root of the first term, and then the square root of our second term, and then we express them as a subtraction according to the pattern, and of course, we square that binomial. Therefore, 4a squared minus 16a plus 16 is equal to the quantity of 2a minus 4 squared. Now we just finished our review. What's new? Look at the picture. What would you feel when you are bombarded with these problems? COVID-19, grades, friends, exams, bullying, and self-esteem. How are you going to deal with these problems? Well, just like in mathematics, here are some suggested steps in solving problems. Read and understand the problem. Make sure that you understand the problem before you try to solve it. And by understanding, you will be able to identify the known and unknown quantities in your problem. And then, you choose a variable to represent an unknown quantity. And, if possible, express all the other unknown quantities in terms of this variable. After that, you translate the relationships of all of your quantities into a mathematical equation. And then, it is time to factor your equation completely. Once you get your factors, you set each factor to 0 and solve again. Finally, you check your answer. Now, let's put that into action. What is it? In this lesson, you will need your prior knowledge about factoring polynomials and its techniques, which we just reviewed earlier. First example, find two consecutive positive odd numbers such that the sum of their squares is equal to 130. We just read, now let's understand. We are looking for two consecutive positive odd numbers. Now, since they are odd numbers, their difference must be 2. For example, we have 3 and 5. These are consecutive positive odd numbers. 5 minus 3 is equal to 2. Now, put that into the corner of your head. We are going to need that later. Now we know that the sum of their squares is equal to 130. This time, let's represent our first number as x and our second number as x plus 2. Remember, the difference between two consecutive positive odd numbers is 2. Okay. Or, for example, 3 plus 2 is 5. 3 and 5 are two consecutive positive odd numbers. Now, we know that the sum of the square of the numbers is 130. And then, expressing that into an equation, so the sum of the squares of the two numbers, which are x and x plus 2, is equal to 130. Now let us solve. We have here the quantity of x plus 2 squared. So therefore, we are going to expand that. It will become x squared plus 4x plus 4. We combine like terms. X squared plus x squared is 2x squared. And then, we have here 4 minus 130 is equal to negative 126. Now let us find the common monomial factor, which is, in this case, is 2. And then we have x squared plus 2x minus 63. This time, let's factor that out. How did we factor that out? Let us get the factors of 63 that if we are going to add them, it will become 2. So that will be 9 and negative 7. 9 times negative 7 is 63. And then 9 minus 7 is equal to 2 here. Okay, let's move on. Now this time, let us equate our factors into 0. So x plus 9 is equal to 0, x minus 7 is equal to 0. Now remember, we are looking for two consecutive positive odd numbers. So therefore, we reject negative 9 because x is positive and choose 7 instead. Now if our first odd number is 7, our next number should be 9. Perfect. Therefore, the two consecutive positive odd numbers are 7 and 9. And lastly, let us check if our answers are correct. We have our first term is 7. Our second term or number is 9. Square 7 and 9, we have 49 and 81. Adding them is equal to 130. Very good. This is our second example. Now again, let us read and understand. 7 times a certain integer is 5 more than twice its square. Find the integer. This time, we look for an integer by which, when multiplied by 7, is equal to 5 more than twice its square. So, let's represent that integer with x. And then, using our knowledge of the problem, we have 7 times a certain integer is 5 more than twice the square of that number. Solving that equation, first by writing into the standard form, we have 2x minus 7x plus 5 is equal to 0. Factoring out, 2x squared are 2x and x, 5 are negative 5 and negative 1, because when we do negative 5 times x is negative 5, 2x times negative 1 is negative 2x, it will give us negative 7x. Okay, now we equate our factors into 0. And then we have here, simplifying further. Now let's go back to our problem. We are looking for an integer. Therefore, we discard the value which is not an integer, which is 5 over 2. And so we choose 1 because that is an integer. Now, therefore, the integer is 1. Let us check if that is correct. Let us substitute that value of x with 1. So 7 times 1 is 7. And then 2 times 1 squared is 2 plus 5 is equal to 7. Perfect. Now let's move on to our last example. Now let us read and understand. The length of a rectangle is 5 centimeters more than its width. Find the length and the width when its area is 150 square centimeters. Now take note here that we are looking for the length and the width. And that the width is the basis for the measurement of the length. In this particular problem, the length of the rectangle is 5 more than the width. So we must know the width first before we get the length. And of course, it is given that the area of that rectangle is, that is right, 150 square centimeters. Now let us represent what we have understood. So again, the width of the rectangle is x because that's the basis for the length of the rectangle, which is 5 more than the width. And the area is 150. The formula for getting the area of the rectangle is length times width. Therefore, we multiply the length, which is x plus 5, and the width, which is x. is equal to the area of, that is right, the area of 150. Therefore, the quantity of x plus 5 times x is equal to 150. Now, distributing the value of our x to x and 5, we have x squared plus 5 is equal to 150. And then, writing in the standard form, we have x squared plus 5x minus 150 is equal to 0. Let us factor out, and it will be the quantity of x plus 15 times the quantity of x minus 10. Again, we get the factors of 150, which when we add, we will get 5. So that will be 15 times 10, or 15 times negative 10 is equal to 150. And 15 plus a negative 10 is equal to 5. Very good. Now let us equate our factors into 0. X plus 15 is equal to 0 and x minus 10 is equal to 0. So again, we are looking for the length and the width. There are no negative measurements. Therefore, we take 10 but reject negative 15. Now if the width is equal to 10, then the length is, that is right, it should be 15. Therefore, the length is 15 and the width is 10. Let us check if our answer is correct. Substituting the values, x plus 5 is 15 and x is 10. 15 times 10 is 150. That is right, bravo! We got the correct answer. Now you are fully loaded to take on our next activity. What's more? Now it's your turn. Activity 2.1. Read the problems carefully and answer using your knowledge in factoring polynomials. Follow the steps suggested above for you to be guided. The square number equals 9 times that number. Find the number. The product of two consecutive integers is 272. Find the value of each integer. The sum of a number and its square is 156. Find the numbers. Mario's rectangular plot is 6 meters longer than its width. The area of the plot is 16 square meters. Find the length and the width of the plot. And lastly, Marilyn has a photograph which is 8 centimeters longer than its width, and its area is 33 centimeters squared. What are the dimensions of the photograph? Alright, so again, you can pause and replay this video as needed. And then forget, guys, please submit your work on time. Can you give me a thumbs up? Yes, thank you very much. Now, what you need to remember. These are points to ponder. Solving problems involving factoring. You may follow the following steps. Read and understand the problem. Identify known and unknown quantities and represent an unknown quantity, and if possible, express all the other unknown quantities in terms of this variable. Translate the relationship into mathematical equation. Factor the equation completely. Set each factor to 0 and solve. And lastly, don't forget to check your answer. And there you have it. Now this is what you can do. In this section, your goal is to apply your learning to real-life situations. You will be given a task which will demonstrate your understanding in factoring. Now look for any rectangular object in your house. Formulate your own problem and show your solutions on how you solved your problem. It will be graded according to the following criteria: explanation of why you have created that problem. Give an explanation why you chose that problem. What is the significance of that problem to you? Number 2, accuracy of computations. Of course, you will need your knowledge in factoring polynomials for this. And lastly, utilization of resources. Now, here's what I can do to kickstart what you can do. What are the different rectangular objects that you can find in your house? A mirror, a cell phone, and a window. Now there could be a lot more in your house, and I hope that these gave you idea on how you are going to work out what you can do. Congratulations! You just finished the second module of Quarter 1. Simple reminders for you. Make sure that every answer sheet has your name, grade and section, and title of the activity or activity number. Submission as agreed with your teacher. Keep the modules with you. Please take care of them. Return them at the end of the school year. As Benjamin Franklin said, "Tell me and I forget. Teach me and I may remember. Involve me and I will learn." I can just teach you so much. You may or may not remember, but get involved in your learning and have a fruitful day ahead. This has been your teacher, Miss Mary Kate. Good luck, everyone!